Hi there, everyone. My name is Mr. Marin, and today I'm going to go over the Exponentials module, a review we're doing for the Spring 2020 Common Assessment. Now, when we start, I'm going to go over just this review page. Let's start by reading the first question. Graph the following in your calculator and identify which is linear, which is exponential growth, and which is exponential decay. Now, while you can, I will draw a sketch and I'll tell you about why I already know that which ones are linear, growth, or decay. This one here, when I put into my calculator, makes a graph that looks something like that. It curves, and because it curves, I know it's exponential. Since it also curves upwards, I know it's exponential growth. The reason I can tell quickly is that this x here is in the exponent spot. The 1.40 is a number greater than 1. We'll chat more about that later. So that means that it's growth. This one here is our next one. I'll plug it into my calculator and get a line that looks something like that. Since it's a straight line, we call that a linear equation or a linear function. Lastly, this one here, 3 times 0.40 to the power of x, still has x in the exponent spot. So before I graph it, I know it's exponential. When I graph it on a calculator, I can see that it looks like this. It starts from a pi and it goes low, curving, which means it's likely called exponential decay. This 0.04 is smaller than 1, so it's a decay function. Let's now go into the next question and better understand growth versus decay. I'll note first to you that the growth or decay rate, the growth or decay factor, will always be within the parentheses, inside of the parentheses. So identify the multiplying factor and whether it is a growth factor or a decay factor. Here, 1.3 is the multiplying factor. And since it's the multiplying factor, I can decide if it's growth or decay. I say it's growth whenever it is greater than 1, so I'm going to say greater than 1. Or decay factor when it is less than 1. I'm going to put less than 1. So I see this as 1.3, that means it's larger. It is a growth factor, growth. Sorry about my handwriting, factor. This number inside the parentheses is the multiplying factor. So once I have that, I can now use the less than 1. 1/2 is less than 1. It's a decay factor. This would then be the multiplying factor, greater than 1. So it's a growth factor. This one here inside the parentheses is the multiplying factor. 1.04 is greater than 1, so it is the growth factor. Now these two here are both fractions or decimals, but the multiplying factor is always inside of the parentheses. 0.6, less than 1. That will be a decay factor because it is less than 1. And lastly, both of these are 9, but the one inside of this is 0.9. That's the multiplying factor, so that makes it decay. This 9 does not mean if it grows or decays, only what's inside of the parentheses. So if I were to draw all of these as a sketch, this one's growing up, this one's decaying down. This one is growing up, decaying down, decaying down. I can tell that those will be the ways they curve because of their multiplying factors being greater or less than 1. Next, it asks me to identify the y-intercepts of all of the above. Because of that, I see a 6. That is the number in the front. That is the y-intercept. 6 is this y-intercept. This one here is a 2 is the y-intercept. 10 would be this one. And I'm sure if you pause the video, you could do the rest of them very fast. But I'll do them with you. 4, half, 9. 4 in the front. Half in the front. 9 in the front. They're all in the front. Those are the y-intercepts. So when I graph them, I can easily put these points already in the middle of the graph. Let's do our last two pieces. We're going to go over this specific set of vocabulary words. We'll do the asymptote, domain, and range. Domain and range are more common. They are the x values and y values that are possible. But the asymptote, that is a vocabulary word unique to exponentials in Algebra 1. The asymptote, as a definition, is the line a curve approaches. Something it gets very close to, but doesn't quite touch. So let's see this graph as an example. The asymptote is y equals 4. Well, on the y-axis, I see that 4 is kind of that line that the actual graph is getting so close to. So I say y equals 4 because that's the level it gets very, very close to. It's always above it, but it gets close. So y equals 4 is our asymptote. On this side, I'll do the asymptote of this side next. It looks like this is getting really close to what number? Think about it. It gets really close to this level right here, 8. So y equals 8 is the asymptote. Domain is our next one. In the example, in this curve, it shows that it goes left forever and to the right forever. Domain, being about x's, always talks about how far left and right the arrows point. So I see that it goes left forever and right forever, thus the domain is all real numbers. In the same way I look at this curve, I ask myself, is it still going left forever and right forever? This arrow is going left forever. This arrow is going up, but also to the right forever. So I know it will also be all real numbers. Another way to write that is a fancy looking R with 2 lines in its bar. Last, we have the range. In this example, it looks like the range for y values is all about up and down. Is this going up or down forever? Well, I see it's going up forever. For that reason, the range is y is greater than. Since we're talking about the range, we're going to reference y. And since it's going up forever, it's going to be greater than. But it's always greater than one level. And it looks like that level that it's always greater than is 4. This exponential curve is always greater than 4. So we say y is greater than 4. This is now our new challenge. For the range, I'll put y. And is y going up forever? Is this graph going up or down forever? I'll let you think. Now this graph is going up forever, so we'll say it's greater than something. What level is it greater than? Well, it's greater than the level of y and 8 and 8. Y is greater than 8. This is my range. In summary, the asymptote is the level it goes to. The domain is if it goes left and right forever, or how far it goes in each side. And lastly, the range tells me if it is going up forever for greater than, down forever for less than, and at what level it changes. Let's go to our last one. The last piece is about growth rates and decay rates. A rate is a special way of saying a percentile. So when we talk about exponential rates, a growth or decay rate is calculated by 1 minus b or b minus 1, and then converted to a percentage. Here's an example of growth. I can tell that 1.05 makes this a growth because this number is greater than 1. To find the rate, I need to decide to subtract 1 in some way between these two. I'll say 1.05 minus 1. When I plug that into a calculator, I get that 0.05. When I convert that into a decimal, 0.05, I always move over 2 places, and now I have 5%. Thus, the growth rate is 5%. In the next one, I have the decay example. This number is the decay factor, but when I want a rate, I need to find its difference from 1. So since I'll have 0.7, I'll put that after 1. 1 minus 0.7, and I get 0.30. 0.30 to convert into a decimal is 30%. That must be my decay rate. It's decay this time because originally the question had a number less than 1. Next on these two, I see that this is my trying. You try this one. Now that you've unpaused, you should see 1 minus 0.97 equals 0.03. When I move over the decimal twice, my decay rate is 3%. Here, try this one now and pause the video. You should now have unpaused and get 1.44 minus 1 equals 0.44. When you move the decimal over twice, you get that the growth rate, since this is bigger than 1, the growth rate is 44%. This has been the review for exponential modules. I hope it has been helpful. You can now move forward to do the problems inside of the exponential model. You should go through all of the problems and reference these if you have any questions on vocabulary or types of work. I hope you have a good time and I hope you enjoyed this review. If you have any questions about the questions inside of these, you can reference the next video about important questions in the exponentials module. Thanks so much. Mr. Sanchez wants you to like and subscribe and all of those other things. Have a great day.